humanity has endured for countless generations. Looking up at the vastness of the awe-inspiring night sky, pondering the myriad mysteries in the universe with no answers. In the 20th century, scientists first developed the Big Bang Theory, an effort to clarify the beginning, growth, and spread of the universe. Nevertheless, despite its widespread acceptance, this theory is unable to respond to some of the most fundamental inquiries regarding the universe. The most recent discoveries have made these celestial conundrums even more complex. For instance, in 2023, NASA's revolutionary observation using the James Webb Space Telescope discovered entities in the cosmos that appear to have existed prior to the universe as a whole. This revelation has astonished experts and sparked discussion about whether it's possible that stars existed for some time longer than the age of the universe. This paradox poses a threat to our current comprehension of cosmic events. Does this anomaly point to the requirement for a completely new framework of the universe? These inquiries and numerous others will be explored in this presentation. If you wish to stay abreast of the most recent cosmic developments, remember to sign up, enjoy the video, and use the bell for notification. A little over 200 light years away in the constellation, Lyra is a star known as HD 14283. What makes this star stand out? The fact that it is moving at an extremely high speed of 4,483 kilometers per second, which offers useful insights into its turbulent history. About 1 billion years ago, during a time when our Milky Way was still forming, it collided with a dwarf galaxy that was home to this particular star. But the most remarkable feature of HD 14283 is its age, not its speed. This star is one of the oldest stars ever seen in the universe, resulting in the nickname Methuselah, an allusion to the biblical figure who, according to legend, lived for 969 years. At first, estimates suggested that its age was a staggering 16 billion years. But more recent estimates have revised that to 14.46 billion years, with an approximate 800 million year error margin. The discrepancy results in a significant conundrum. In comparison to the current estimate of the universe's age, approximately 13.8 billion years, as determined through observations of the cosmic microwave background. This creates the pressing question: what is this gigantic structure? What makes a star older than the universe itself, which seems impossible based on our current understanding? As a result of this paradox, scientists are prompted to reevaluate the precision of our methods for dating both stars and the universe, prompting further examinations of these astronomical mysteries. To better understand this problem, it is essential to comprehend the difficulties encountered in calculating the age of celestial bodies. Stars, like our Sun, hold relatively steady temperatures and dimensions over billions of years, making precise age determination difficult. Astronomers examine the minute changes in a star's brightness and color over time, then compare these findings to theoretical models predicting the life of stars. One important indicator for determining a star's age is its speed of rotation. Just as a spinning wheel is slowed down by friction, stars gradually slow their rotation. By comparing the speeds at which stars rotate at various ages, astronomers have developed mathematical formulas that allow them to estimate a star's age, using a method known as gyrochronology. The Methuselah star in question is, in fact, ancient. It is, according to current estimates, the universe's oldest known star. Instead of wondering if it might be older than its surroundings by more than 2 billion years, we can approach this from a new perspective. Could it be that the universe is older than we thought? Acknowledging the vastness of 13.8 billion years is no simple task. If we were to simplify the history of the universe into a cosmic calendar, where the event of the Big Bang marks New Year's Day, Earth would only emerge toward the very end of December 31st, whereas the duration of human history would be the final few moments of the year. Astronomers calculate the universe's age By studying the distant light of stars that formed millions of years following the Big Bang, while the universe continued to grow, resulting in the occurrence of redshift, by evaluating both the observable distance and the universe's expansion. The current estimate for the universe's age consists of 13.8 billion years. Nonetheless, new research from the University of Ottawa has presented a fascinating theory implying that the universe could actually be significantly older, around 26.7 billion years. Professor Rajendra Gupta, a professor of physics at the University of Ottawa, has proposed a scenario that combines Fritz Zwicky's 1929 astronomy theory from Switzerland with brand new ideas in physics. He proposes in his theory that over vast distances, protons lose energy and time, an idea that goes against current data about redshift. Gupta asserts that by permitting this theory to coexist with the expansion of the universe, redshift could be reinterpreted as a hybrid phenomenon, not solely attributed to expansion. This new understanding could result in a new age estimate of the universe, conceivably providing solutions to long-standing cosmological questions, some of which have recently emerged in response to NASA's findings. Gupta's work builds upon the tired light theory as well as the idea of evolving interaction constants proposed by Paul Dirac, a theoretical physicist indicating that particular cosmic interactions may have changed over time. It's critical to keep in mind that our understanding of the universe's age has changed through the years. For instance, in the 1920s, Edwin Hubble proposed that the universe was only approximately 2 billion years old. However, subsequent observations have significantly raised this estimate, achieving the currently accepted timescale of 13.8 billion years. Regardless of whether we think of human history as just 10 seconds or 5 seconds on the grand cosmic scale, the universe is unmistakably, exceptionally ancient. It continues to force us to reevaluate earlier assumptions about its age. In addition, fascinating recent discoveries are surfacing about our own galaxy, the Milky Way. Newest evaluations indicate that stars in its extreme regions travel through space at significantly slower speeds than those in other galaxies. Multiple possible explanations have been suggested for this phenomenon. One theory is that our galaxy may contain a significantly lower proportion of dark matter, a substance that cannot be seen but contributes significantly to the gravitational dynamics of astronomical structures. An alternative explanation is that our current scientific grasp of dark matter and how it is distributed across the cosmos might be completely wrong. Data gathered by the European Space Agency's Gaia spacecraft, which has meticulously mapped the positions of nearly 2 billion stars in the Milky Way galaxy, provide the basis for this conundrum. These observations have driven scientists to reevaluate their stellar movement models, especially at the edges of our universe. The rate of star formation and travel is an important part of determining the total mass of a galaxy. Since gravitational interactions affecting stars depend on the galaxy's overall mass. A recent study using Gaia's measurements suggests that the entire mass of the Milky Way, including gas, dust, dark matter, and stars, is possibly 200 trillion times the mass of our Sun. This figure is nearly 5 times less than what earlier assessments had proposed. This downward revision could result from a surprising lack of observable matter in our galaxy, suggesting it may harbor far less dark matter than previously thought. Nevertheless, measuring the mass of a galaxy is an extremely complex undertaking, and there may be a margin of uncertainty because of either the analytical methods or the data from Gaia employed. As additional details become available, researchers will keep close attention to these developments. In the coming years, advancements in technology and future space missions are expected to shed more light on these cosmic mysteries, illuminate these unanswered astronomical riddles. The James Webb Space Telescope, due to its unparalleled capacity to capture and examine imagery from deep space, is ready to push the boundaries even further of our cosmic understanding. It is not only the age of the universe or stars that our goal is to decipher, but also the nature of galaxies, their complex behavior, dark matter, and the fundamental forces that govern the transformation of the universe. It's a continuous growth of the universe continues to be a central idea in contemporary astronomy. However, as additional data accumulates, we may come to realize that some of our prior beliefs were incorrect or possibly incomplete. A significant question arises. Do the familiar laws of physics remain the same everywhere, in every era and scale of the universe? Might there be unknown forces or elements shaping the behavior of galaxies and determining the lifespans of stars? As our tools for observation become progressively more advanced, we may reveal facets of the universe that require us to confront even our most deeply held scientific convictions. Researchers are becoming increasingly aware that our current comprehension of dark matter, dark energy, and the essential forces of nature could be far from comprehensive. Every new revelation, from structures in distant galaxies to important ancient stellar artifacts, provides clues about the grand architecture of the universe. Yet, these discoveries often generate even more questions, requiring us to go beyond the frontiers of conventional wisdom. The assertion that stars could precede the universe in age or that the cosmos itself might be much older than current models suggest encourages us to reconsider the entire framework of contemporary cosmology. This reappraisal may demand the emergence of brand new physical principles, updated theoretical structures, and possibly revolutionary perspectives on space, existence, and time. Additionally, these developments raise deep philosophical and existential concerns regarding the nature of reality and humanity's role within this vast and mysterious expanse. Should such findings be verified, they would impact more than just our scientific perspective. They could significantly change our broader perception of existence as a whole, as the debate regarding the actual age of the universe continues to unfold. It becomes increasingly obvious that we are at the beginning of a brand new era in astronomical discovery. It's possible that the coming decades will provide answers to questions that have confused people for millennia. Whether it's uncovering the presence of ancient stellar bodies, deciphering the enigmatic properties of dark matter and dark energy, or identifying unanticipated cosmic influences, the universe still conceals a multitude of secrets awaiting revelation. The path ahead is one of curiosity, rigorous experimentation, and continual refinement of our interpretations. Though definitive conclusions may remain out of reach for now, the excitement of discovery is just getting started. Stay tuned for a more in-depth investigation of these potentially paradigm-shifting ideas and breakthroughs. Keep your wonderment alive. Few can deny how incredible dimensions of knowledge lie just beyond the horizon. If you're passionate about staying informed on the most current advancements in space, science, and astronomy, ensure that you sign up for our platform, hit the like button, and enable alerts so you never miss a future revelation. As we probe further into the cosmos, the future is rich with the promise of transformative findings. The James Webb Space Telescope, with its revolutionary imaging technology, is anticipated to be a major driver in uncovering the most profound aspects of the universe's secrets. It has already begun to reveal captivating new aspects of far-flung exoplanets, galaxies, and other cosmic events. Yet, this marks only the beginning. As Webb's mission is carried out through the vastness of space, it may gather information regarding our most pressing concerns and essential beliefs about the way the universe works. Among the most exciting aspects of this investigation is the ongoing search for planets capable of supporting life. With newly discovered exoplanets located in habitable zones, the possibility of finding extraterrestrial life appears more likely than ever before. While these findings do not confirm life, they significantly expand the possibilities beyond Earth and rekindle hope that living things could flourish elsewhere in the cosmos. Even the detection of common microbes on a different planet would have extraordinary implications for science and philosophy, revolutionizing our understanding of biology, evolution, and humanity's place in the cosmos. Furthermore, as our investigation into the enigmatic domains of dark matter and dark energy progresses, existing scientific paradigms will likely be challenged and refined. These obscure components comprise the majority of the mass and energy content of the universe. Yet their precise characteristics and impact on the universe's structure remain largely hidden. Some of the most compelling theoretical questions in physics today revolve around finding the actual nature of dark energy and dark matter and figuring out how they influence the evolution of the universe's expansion. If researchers are successful in solving these puzzles, it could unleash revolutionary insights into the very skeleton of reality. At the same time, galaxies' behavior and evolution continue to be a major focus in astrophysics. Evidence from observations that stars at the edges of the Milky Way are moving slower than anticipated has prompted specialists to reconsider conventional models of galactic motion. This new information may suggest that our galaxy, and potentially others, contains less dark matter than previously calculated. If so, it might significantly alter our understanding of gravitational laws and the underlying architecture of the universe. This situation perfectly illustrates how fresh empirical evidence can lead researchers to reevaluate even the most profoundly ingrained theories, occasionally reversing the basic principles of cosmology. Similarly, the conclusion that galaxies can go through procedures that are not fully comprehended highlights the need for a more complex and intricate approach to studying the cosmos. Is it possible that the universe is significantly older than currently believed? Might there be epochs or important events in the cosmic past that are still undiscovered? These are the questions that physicists and astronomers will continue to pursue as they analyze new findings from existing and upcoming space exploration. As the universe slowly reveals its dark secrets, it is becoming more and more obvious that our current models are not the final word. Much remains to be investigated, and with each new breakthrough, we're reminded of the sheer magnitude of what we are still unsure of. This enduring sense of wonder and our never-ending search for knowledge form the foundation of scientific research and discovery.